Okay, so stuff that you should know about a rational function. So this is like y equals, 2x plus 3 over x minus 2. Like it's a fraction that we're looking at. Where do horizontal asymptotes come from on our equation? What do we look at to find a horizontal asymptote? What are you saying, Christian? The front ones. What do you like leading coefficients? Yeah, the front ones. That's mathy. Okay, part of the time we do that. When do we do that? If it's the same. Okay, if it's the same degree. So if it's balanced. Oops. We'll say that it's y equals, and I'll say leading coefficient over leading coefficient. If you want to write down front one over front one, you do that. That's fine. Whatever makes sense to you. What else could happen? Yeah, Adam. Okay, that's going to come down here for the slant asymptote. And this is where we have to do long or synthetic division to find the asymptote. Yeah.
Degree is higher, or the asymptote.
Yes. Okay. So it's bottom heavy. We just end up with y equals 0. You forgot all of this. Oh no. Okay. You've heard of this before. You just don't remember how to do any of it. Okay. All right. Vertical asymptotes. Where does that come from? Denominator. Good. What do I do with the denominator? Okay. So it's the values of x that make the denominator equal 0. And I'll abbreviate a lot. And guys, realize this is after reducing, okay? I'm not going to fill in domain and range right now. We'll look at those when we actually do the graphs. X-intercepts. For some reason, this is always the hardest part for you guys. Okay, so it's where it crosses the x-axis, right? And that happens when y equals 0, yes? So let's think about that. If y equals 0, that means your entire fraction is being set equal to 0. How does a fraction equal 0? Yeah, so really all we care about is when the numerator equals 0. Okay, that's what makes a fraction 0. So numerator equals 0. I'm abbreviating a lot, so. Can you have more than one x-intercept? Yes. Okay, good. What about the y-intercept? You can only have one of those, right? Okay. And how do we find the y-intercept? Yeah, so it's when x is 0. Again, skipping over domain and range right now because we'll look at a graph. Do you guys remember the other thing we should probably talk about? Poles, yes. Okay. How do I find the whole of a graph? Yeah. Common factor, yes. Common factor. Numerator and denominator. So let's say I find that common factor. I'm just going to make you a little example here. Let's say I end up with x plus 2 times x plus 1 over x plus 2 times x minus 3. X plus 2 factors and cancels out, right? Okay, what does that mean? Like, where is the hole then? Okay, when x equals -2, all right, I need a little more than that. How do I find the y part of the hole? Go ahead, Alex. Yeah, so you've reduced, right? We've crossed those out. Take that -2 and just plug it into what's left. Plug it into your new reduced fraction. You can't go back to the original because you'd end up with 0 over 0, which that should tell you, oh no, don't do 0 over 0, okay? So if I plug a -2 into this, let's see, I get -1 over -5, so 1/5. You need to actually be able to draw where the hole should go on your graph, okay? It's not just a random x equals -2 and whatever y value you feel like. Okay. All right, let's actually try one. Sorry, that thing is annoying. I'll get rid of it in a second. All right, let's do f of x is 2x minus 6 over x plus 4. We're going to graph the whole thing before we look at domain and range. All right, I could factor this, but will anything cancel with factoring? Does anything go away, really? No? Okay. That's all right. So are there any holes in this graph? No. So none of those. Where is the vertical asymptote? The vertical asymptote.
-4, yeah.
Hey guys, when you tell me asymptotes, don't just write down, like, don't just say, oh, -4. What does that really mean? What's the equation of the vertical asymptote? X equals -4. And yes, we will draw a dotted line at -4. All right, what's my horizontal asymptote here? 2, so y equals 2. Okay, x-intercept. Remember, that's where y is 0. How do I find it? Yes, the numerator equals 0. So what's it going to be this time? 3. Good. I'm between yawns over there. Haven't even eaten lunch yet. I'm worried about you after lunch. Okay, 3, 0. Y-intercept, that's when I plug 0 in for x. What do I get this time? So -3/2, right? So right down here. We know -3/2 is -1.5, right? Okay, just checking. All right, so as far as drawing the graph goes, I definitely have enough to draw the right side of my graph. Guys, I am not looking for perfection here. I am not looking for some gigantic table of values that you've plugged in. No, that's not what we want. I want you to understand that the asymptotes help guide the shape, and you're definitely going to have to hit your two intercepts here. So there's the right side of the graph. Where do you think the left side of your graph is going?
Okay, wait. -4.
If you're not sure, you can plug it in, but I think a lot of you recognize, like, which of these two is it going to be at the top one or the bottom one? Top one. Yeah, usually they're going to be across from each other. If there's some sort of multiplicity going on, then they, then they won't be. Then you have to think about it a little more. If you're unsure, just pick a number on this side of the asymptote and plug it in. But again, pick like one number. Don't pick 5 numbers and flop them. What if I pick -6? When x is -6, what does that give me? Nine. Okay. So 3, 4, 5, 6, 7, 8. I can't count. 1, 2, 3, 4. 9 up there. And then use your asymptotes. Again, is my graph perfect? No. Does the graph go through that point exactly? Probably not. This is just the general shape that we're looking for. Okay, we want to make sure it's in the right section. Horizontal asymptotes, can I cross them?
Yes.
Yes. What is a horizontal asymptote? What's its sole purpose in life? Yes, tells you about the ends of your graph. That's its only purpose. We draw it all the way across the graph just because we're used to doing that, but it really doesn't mean anything in the middle of your graph. Now, a vertical asymptote is different. You can never cross or touch a vertical asymptote. But horizontal asymptotes, when you get like the 2 verticals and weird things happen in the middle?
Yeah.
Yeah, so sometimes you end up crossing a horizontal asymptote. Okay, we'll pause there. Go to lunch. All right, so we still need to do domain and range of this, and then we can move on to the back. So what is your domain for this graph?
-infinity to -4, -4 to
Good. And what about our range, guys?
-infinity to 0.
Good job. Aiden's on a roll. All right, so questions on the first one. Okay. Let's try a new one. Let's do. All right, let's try f of x equals 5x plus 1 over x squared minus 1. All right, guys, are there any holes in this graph? No. Vertical asymptotes. Yes. We have 2 of them. Plus or minus 1. I hate it when they're that close together, but we'll survive. I realize I could have changed the problem, but that's okay. All right. So those are some really terrible looking asymptotes. But anyway, we've got our asymptotes. What about the horizontal asymptote? 0. Why? Bottom heavy. And remember, give me the equation. So it's y equals 0. All right, x-intercept. Remember, that's where y equals 0. Very aware we have a horizontal asymptote at 0, but does that matter? No, remember? Its only purpose is to tell me what the ends of the graph are doing. So, when would this fraction equal 0? I'm hearing mumblings, negative 1/5. So negative 1/5, 0. So somewhere over there. You can almost see my dot on my graph. Kind of. It's just a big blob in the middle. And then your y-intercept, so that means when x is 0, what do we get? Mm-hmm. All right, so that's great. Looks like an awesome graph, right? Okay, we got to figure out what else is going on. So I need to figure out on the right side of the graph, so past that vertical asymptote. Again, you can plug it in all the way and find the exact point, but really what I need to know is it up here or is it down here? So what could we plug in to check? It's almost like your number line test, guys.
2.
Plug in a 2. So 2 in the numerator gives me
4. It gives you 3.
2 in the numerator gives me 11. 2 in the denominator would give me 3. 11/3, clearly a positive number, right? Almost 4. Yeah, okay, so I could go to almost 4, put a dot. So I know this side. What do you want to check on the far left side of your graph? Okay, so negative 2 in the numerator. A negative over a positive, right? Negative 9/3, so like negative 3. Definitely down below. And again, I don't care if you go and plug it in all the way or if you're just like, negative over positive, that's definitely going to be negative. I know where my graph is going.
You don't really need to make that point.
No, not unless you are just awful at drawing things and it just looks nothing like a graph that we would want. That would be the only time I'd be like, yeah, you need to plot some points, okay? Now in the middle, clearly more is happening than just those 2 dots, but we got to figure out what is happening. So in between asymptotes, you either end up with kind of a cubic looking graph or you end up with like a parabola shaped, it's not a parabola, but that kind of shape, either up or down. What do you think is happening here? It looks like cubic. You could even plug in a half if you wanted to. But do you guys see how that would give you a negative value? Because the denominator would be negative. Okay. So yes, it is this wonderful squiggly looking thing that follows your 2 vertical asymptotes. All right. Usually the multiple vertical asymptote graphs are just kind of the most painful to do. All right. Okay, what would you tell me for domain on this one? Okay, and what about the range? Good. Okay, so even though we have that horizontal asymptote, the range is still all real numbers. We see it? Okay. Questions on that one? All right, moving on, guys. Stop me. I'm moving pretty quickly today, so stop me at any point if we have an issue, okay? All right, f of x equals x squared minus 3x plus 2 over x plus 1. Move it up for you. So we can go ahead and factor that. What does the numerator factor into? X minus 1, x minus 2, right? Over x plus 1. Okay, so nothing reduces. That's okay. That's still going to help us as we graph. So can we say none for holes? Everybody's okay with that? All right. Only one vertical asymptote this time. Where is it? Give me the equation. Where is it? X equals -1. Okay. Draw that guy. Okay, do I have a horizontal asymptote this time? No, I have a slant, right? So let's change that word to slant. Sometimes slant asymptotes are called oblique asymptotes too. So if you ever see oblique, I'm not talking about your abs there. That's it's an asymptote. Okay. To find the slant asymptote, we actually have to do division. Top heavy? Yep. Can I do synthetic this time? Yes, I'm dividing by x plus 1, so I'm going to do teeny tiny division in here, okay? 1, -3, 2. 1, -1, -4. Guys, I can stop there. I don't have to find the remainder. The remainder is insignificant when we go to graph the slant asymptote, so I could stop right there. And this is just y equals x minus 4. That is the equation of my slant asymptote. How do I graph that?
Oh, yeah, you just...
It's a line, right? Do we know how to graph lines? Start at -4, yep, 2, 3, 4. Slope is 1, so then it's just a dashed line. Do you see why it's called a slant asymptote? It is slanted. Okay, that's it.
Why not? It's like
So you could do it, and it's okay, 4, 6, and so then it's x minus 4 plus this teeny little 6 over x plus 1. Well, first, do you really want to graph a line with a remainder? No, okay. And it doesn't impact what the graph looks like, so we just don't need it. Okay. All right, x-intercept or intercepts. How many do I have this time? 2 of them. Where are they? 1, 0, and 2, 0. How did I find those? 0 equals the thing. Yes, absolutely. Just like the front thing and the front thing. Yeah, we're good with our math terminology today, guys. Yeah, the fraction equals 0, which means the numerator has to equal 0. Okay. All right. Y-intercept, what's that going to be?
That would be
2, 0, 2. Okay. All right. So I have those 3 points. Okay, so again, the asymptotes guide your shape. I do have to actually try to touch all 3 of those points though. So something, hopefully yours looks better than mine. Got the sort of weird slanted shape going on there. Guys, where's the rest of the graph going to be? Yeah, like this down here somewhere. Yep. And that's all I need. I don't care about the exact point that it goes through. Yeah.
So this is like slightly off topic, but I'm kind of interested. What if it was like a greater than sign? F of x is greater than that.
Okay, so then you'd have to graph it and figure out where you're shading inside your little like U-shaped things, and
Okay.
I'm not gonna make you do that.
Yeah.
But it is something you could think about though. Okay. All right, we good so far? Okay. Oh, sorry. Oh, we didn't write domain and range, did we? we're not going to do range when you have slant asymptotes. Because did I draw this perfectly? No. Do I really know where this is? No, I don't know. And I don't know. Maybe this came down a little more and did something. I don't know what that point is. So if there's a slant asymptote, I will not ask you the range.
Or would it just be like some weird decimal?
You don't really know enough yet to find like the minimum of that and the maximum of that. So, but what we could write domain, right? What is that going to be?
Negative infinity to -1.
All right, guys, I'm starting to think Aiden's the only one who can do domain for me. All right, now are we okay? If I only ask domain, you'd be on fire. All right, let's do x squared plus 2x minus 3 over x minus 1. Okay, should I write the vertical asymptote first? No, what should I do? Yeah, I need to factor because there is a hole on this one. So what does the numerator factor into?
+3 minus 1.
Okay. All right. X minus 1's canceled, right? So I know that there will be a hole in this graph with an x value of what? 1. Okay, realize your reduced fraction is now just f of x equals x plus 3. Correct? Like that's all that's left? Okay, so can I find the y coordinate of the hole?
Yeah.
What would it be?
4.
4. Good job. 1 plus 3. You guys nailed it. All right, so I'm going to go over to 1, 4, and I'm going to just draw a little open circle on my graph. Okay, now before you go doing a whole bunch of work here, this is what's left. If I gave you this equation and said graph it, would you be like, oh, that's top heavy and I need to find a slant asymptote? No, what would you do with this? It's a line, so just graph a line. Don't think about all this stuff. It doesn't matter once you've reduced it. So,
Wait, but isn't the thing implied?
there's not. There's only the hole. You only find the vertical asymptote after you've reduced. So is there a vertical asymptote in that? No. That's what I mean. Don't make these harder than they are.
Wait, but what about that?
As I did last year.
Yeah, like it was
If you plug in
implied.
negative 3 on the original equation, it would just make it.
If you plug in -3, are you good? Okay. There's really weird scenarios where it's like let's say it was x minus 1 squared in the denominator. Then you've got like a whole and an asymptote going on, but that's not what we're looking at right now. Okay. So this is just the line y equals x plus 3, and you just graph the line. See how your hole is right on the line there? There you go. That's it. So the weird x squared plus 2x minus 3 over x minus 1 is just a line with a hole. Yes.
So is like when the x minus 1, those cancel out and stuff, is it when you're trying to find zeros, like you still remember those?
Sure. What's the x-intercept going to be then?
The x-intercepts?
Yeah. Yeah, right? And what's the y-intercept?
-3.
Yeah, okay, and aren't those happening on my graph? Like, yeah, it's still the same thing. Because technically it is over 1. You could think of it that way. And if you really wanted to say, ooh, that's top heavy, and I have a slant asymptote, yeah, you do. It's x plus 3, okay? It is your line. So your graph will follow that slant asymptote perfectly. But you don't have to do that, okay? You can just graph all in. All right, we okay with graphing rationals? Okay, turn the page when you're ready. All right, that's the stuff that was review. Ready to move on? This, you've seen some of it before too, so. All right, guys, so the first one here, x minus 6 times x plus 1 is greater than 0. We've talked about solving this when we did domain in Unit 1. You can think about what the graph would look like as far as a quadratic, or a polynomial for any of these for that matter. Or you can do a number line test, okay, and think about multiplicity, all of that. I'm going to show you the number line test again just because it's something that's pretty useful when you move on into calculus, so I want to make sure you're good at it. But again, you can think of the graph too. You know that's a parabola, it touches the x-axis at these places, and think about where it's greater than 0. What are the two numbers on my number line going to be? Okay, -1 and 6. What number do I like to plug in because it's easy? I cannot plug in -1 because that will give me 0. How about 0? Isn't 0 nice and easy to plug in? Okay. And silly question, but where is 0 on the number line I just drew? Like which section? In the middle. Okay, that's the region I am testing right now. So if I put a 0 in, 0 minus 6 is negative. 0 plus 1 is positive. So overall, that region is negative. Will this alternate? Seeing a couple of nods and a couple of these and a couple of I won't make eye contact and she won't call on me. It will alternate. The only time it doesn't is when there's even multiplicity. Think about our sketching polynomials, right? When we did that, let's say you had like y equals x plus 2 squared times x minus 1. Something like that. Don't draw this, just pay attention. You knew that like the ends, one was up, one was down, and you knew that was going to bounce and then cross, right? So left of -2 was below the x-axis. And on this side of -2 was also below the x-axis, right? Below the x-axis means less than 0. Above the x-axis is greater than 0. So it went negative, negative, and then positive. All because of this multiplicity. If that's not there, it just alternates. Negative, positive, negative, positive. That's what you're starting with. Okay? So please don't plug numbers into every single region. Use what you know to make this quicker. So I'm going to positive, positive. All right. It is asking me, when is this greater than 0? So do you think that's the positive x or the negative middle? Okay. What about the -1 and the 6? Do I want them or not?
No, it's not equal.
Right. So my answer is negative infinity to -1 parenthesis, and then union parenthesis 6 to infinity. Do you guys see how that's very similar to the domain stuff we were doing? Okay. All right. Let's look at number 2. I know you're not going to like number 2, but that's okay. Does it factor? Not easily, not just by grouping, right? So, give me a skill that you guys now have to figure out one of the zeros of this. P over Q. So, P over Q, here we go.
I don't want
So let's see, I'm gonna have 1, 2, 3, 4, 6, 12, and then 1/2, 3/2. Are you guys okay with me just jumping to that? Like,
What? Oh, yeah.
maybe not? Are we okay?
Yeah.
Yeah, okay. Let's try -2, guys. That was obviously your first instinct, right? -2? Okay. Amazing! I got 0 as a remainder.
Oh my god.
How did you guess?
I'm just so lucky. I don't
It's a message from the Lord.
All right, so now I have 2x squared minus 13x plus 6. Could I continue factoring that? Hopefully we can factor that one, right? 2x, x, how about -1 and -6? Are we okay with that? Okay. What's the other factor of my original? X plus 2, right? And then we got to remember what we're actually doing. It wasn't just solving. It was figuring out the solution to this inequality. So where is it less than or equal to 0? So how many things will I have on my number line this time? 3. What are they? Okay, and make sure they go in order. So -2 is on the left, then 1/2, and then 6. Okay, what do I like to plug in? 0. 0 in the first parenthesis will be, okay, 0 in the second parenthesis, negative, 0 in the third parenthesis, positive. What is a negative times a negative times a positive? Positive. And everybody's okay with why I'm putting that in that section, right? Okay. I tested 0, right? So if I test 0, I got to figure out which region 0 is actually in. 0 is between -2 and +1/2, right?
Yeah.
Yes.
Yes.
Yes? Okay, good. I just want to make sure that someone's not sitting there going, what world is that? Okay. So that's positive. What do I know is going to happen? They will alternate signs. Why? No multiplicity. Yes. So this will be negative, negative, positive. All right. Are you with me? Ethan, troubles. Why does it? Okay. Were you okay with us figuring out that this is positive? Okay. These factors, none of them are like squared or to the 4th, anything like that, right? They're all just linear factors. That means your number line will alternate. So if this is positive, it's going to be negative on that side, negative on this side, positive here.
Oh, okay.
That's what I mean by alternate. It's like those signs are going to go plus, minus, plus, minus. Yeah.
So if it was 2x to the third,
Okay, it's the factored part if the quantity is cubed, like, so if it was 2x minus 1 quantity squared, that would mess with the alternating signs. Okay. All right, now again, think. What am I asking you?
If it's less than 0.
Less than or equal to 0. So is that the negative parts or the positive parts? So that's over here, and that's in between here. What about the -2, 1/2, and 6?
Yes.
Yes. Okay. So your answer is -infinity to -2 with a bracket. And then bracket 1/2 to 6 with a bracket. It wasn't that bad, right? Questions on that one? Okay, so if it doesn't factor right away, you might have to think about P over Q. Let's look at 3. I need a 0 on one side. You can't ever do it unless there's a 0 over there. Does that factor? Is there anything that multiplies to give you 10 and adds up to 6?
No.
No. Okay. Would I need a P over Q list if it's already a quadratic? No. Okay. Don't go nuts with your quadratic formula yet either. Let's just think about it for a minute. If it's quadratic, think about what this graph is doing. You know the shape, right? Okay, parabola. Is this an up-facing parabola or a down-facing parabola? Up. And do you guys see how every number is positive? That means the parabola is somewhere above the x-axis, right? It's been shifted up at some point. I don't really care about where exactly the vertex is, anything like that. I just know it's somewhere up here. Okay? Are you with me on that? Then let's look. It says, when is it greater than 0? Here is 0. Okay. And we're going to write it like that. Okay? Good. So, yeah, if it had been like negative x squared minus 6x minus 10, that's definitely a downward facing parabola. It's been shifted down. Okay. On the one we did here, what if I had asked you when is it less than 0? Never. So no solution. Okay. All right, let's look at 4. Okay, so now we have a rational inequality. So good times. We still need a 0 over there. So I'm going to subtract 3. And I'm leaving a little bit of space here. I'm doing that on purpose. I'm not just weirdly writing. All right, so 3 could be over 1. If I want to subtract fractions, what do I need? Okay, and what's it going to be this time? Okay, so I need a little x plus 4 here and a little x plus 4 here. So, I know the denominator will be x plus 4. All right, x minus 3, that first numerator, that's not changing, right? Then you have to distribute. Just be really careful with your negative here. So this is going to be minus 3x. And then do you guys see minus 12? Okay. All right, so simplify your numerator. We'd have negative 2x minus 15 over x plus 4 greater than 0. All right, we're okay there? Okay, now it's time for our number line. So, what do you think goes on my number line? I'm going to have 2 things. Guesses. What might go on there? Negative 4. I like that. Negative 15 halves. Yes, so you'd add 15, divide by negative 2. Yeah, it's anything that makes your numerator or denominator 0. That's what we want to look at on your number line. Okay? So negative 15 halves. Everyone's okay with that would come before negative 4. Right? We get that? Okay. Just making sure. All right. I still want to plug in 0 because it's easy. 0 in the numerator. What is that going to give me? Negative. What about 0 in the denominator? Positive 4. Yes, okay. It's a fraction, guys. A negative over a positive. What is that? Negative. Okay. All right. Again, do you see any multiplicity? Like, is your denominator x plus 4 quantity squared? No. So what will happen on your number line? It will alternate. Okay. And then what am I asking you? Okay, so between there, am I including? No, okay. So it's going to be parentheses, negative 15 over 2 to negative 4, parentheses. Okay. We're actually going to skip 5 and do, yeah, we'll skip 5 and do 6. Okay. I want you guys to try 6. It's a lot like 4.
So, like, you brought the 3 over, you're gonna wanna bring the 3 over.
Okay.
If you do this, you'll use half your solutions. Looks very reasonable. I would think about what's
All right, guys, I'm going to start it up here just to make sure we get through everything today. All right, I need a 3x minus 5 this time, right? So guys, on your number line, you should have 14/13 and 5/3. Okay with that? All right, which one comes first if you're putting them in order? Okay, good. And 5/3. A couple of you I know, just easy to mess up the simplifying of the numerator with the common denominator. It happens. It's okay. I'm going to plug in 0. 0 this time's way over on the left, so that's going to give me a negative 14 over negative 5, which is positive. Will it alternate?
Yep.
Yes. Okay. Now, exciting conclusion. All right, greater than or equal to 0, right? So are we okay with that's the outside edges? Okay. What about the 14/13 and the 5/3?
Right, okay, so would you include the 5/3? Because I'm assuming not.
Correct. You would have negative infinity to 14/13 with a bracket, and then a parenthesis 5/3 to infinity. Okay? Do we get why? What would happen if I included 5/3? Yeah, you'd be dividing by 0. We can't do that. Okay. All right. How do we feel about nonlinear inequalities? Good. We're not done yet, guys. Okay. Turn the page. All right. Now this is the stuff that you've never seen before. Partial fraction decomposition. Okay. Let me walk you through one, and I'll explain like what's happening and why it's happening as we're going through it. Basically, you are like undoing a common denominator. That's what's happening. So we've had this nice singular fraction, and we're going to break it up into pieces. Okay? So I'm going to start with x minus 1. Actually, I don't need to rewrite it. Sorry, guys. We can just use what's there. All right, this is going to equal.
Wait, like we don't know what the common denominator is.
It's like you're going back to, so if you see this fraction with these two denominators multiplied, that means at some point you could have had two separate fractions, one with each of those denominators, right? But we don't know what the numerators of those fractions would have been, and that's what we're gonna find. So I'm gonna write a over, and then the first factor, which was 3x minus 5, that factor of the denominator, plus b over x minus 3. You see what I mean? So you guys are used to starting with what's on the right and saying, oh, I'm adding fractions, I need a common denominator, and you turn it into what's on the left. We're working backwards, okay? So I need to figure out what a and b are. Okay. If I wanted to make this so there were no longer fractions anywhere, what would I multiply my entire equation by?
3x minus 5 multiplied by x minus 3.
Okay. So the left side of my equation would then just be x minus 1. What would I end up taking a times?
X minus 3.
Good. And what about b?
3x minus 5.
Okay, let me stop there for a second, make sure that's like clicking with your brain what's happening. Because we're not writing everything out right now. I'm not showing you how everything reduces, because I think we're past that. Okay? You see it so far? All right. Let's keep going. So x minus 1, I'm just going to distribute here. I'm going to say that equals ax minus 3a plus 3bx minus 5b. Yep, we've got x's and a's and b's. That's okay. Promise you're okay. All right, x minus 1.
Passengers in the crashing plane.
It's going to be okay, guys. It really is. Your oxygen masks will deploy soon. All right, I'm going to kind of group together the things that have x's and then the things that don't have x's. Question? Or okay. So I'm going to, you don't have to write this step, but just so you can see kind of where I'm going. So ax plus 3bx, and then I'm going to say minus 3a minus 5b. Okay, those first two terms, what could I factor out of them? An x, and I'm going to write it differently than you're used to seeing. I'm going to write what's left over, the a plus 3b, and then the x. You'll see soon. And then I'm going to kind of put this minus 3a minus 5b in a little group over here. You don't have to. We're just kind of like, all right, these are their own thing. This a plus 3b, what is that? Do you know what that's representing? So are A and B just numbers? Like we're trying to find those numbers. What'd you say? Yes, the coefficient. It's that front thing, you know, the coefficient on X, right? Isn't this all just one number? Eventually it will be, yes, on X. All right, on this side of the equation, what's the coefficient on X? 1. So I can now say, we're going to go over here where I have more room. I'm going to say 1 equals A plus 3B. It's not cheating. I know, it's cool. So then this negative 3A minus 5B, isn't that all just a constant? Right? No variable. Okay, no. There's A's and B's, but no X's with it, right? No, none of your normal variables. This is a constant. What was the constant over here? Okay, so I can say negative 1 equals negative 3A minus 5B. Okay. It is a system of equations. All right. You learn how to solve systems with substitution, with elimination, with what else? Graphing. We're not going to graph this to find where they intersect, okay? What do you guys want to do? Okay, you can substitute. I'm going to eliminate. You do whatever you want to do. Try to find your way there. I'm going to go ahead and take this first equation times 3, and then I'm just going to write it down below. So I'm going to have 3 equals 3A plus 9B. But if you want to substitute, you certainly can. If that's like your wheelhouse, go for it. I'm going to end up with 2 equals 4B. So I know 1/2 is B. So that's one of my little answers. Once I know one of them, what do I do? Plug it in. And I don't care where you plug it in. You can pick this top one, the second one. If you really like that third equation, you go for it. It'll work in any of those. I'm just going to do it in the first one. So I'm going to say 1 equals A plus 3 times 1/2. So I really have 1 minus 3/2 equals A. What's 1 minus 3/2? Negative 1/2. Question? Okay, so I was doing elimination. All right, so these were my 2 original equations, right? To eliminate, I need variables to match, so I multiplied by 3. I wrote it underneath, and then I added my 2 equations together. Do you see it? So like this is equivalent to this. It is a lot of writing up there. All right, now how you actually write your answer. You don't just tell me what A and B equal. You have to go back and write them within your like weird fraction at the top. So instead of A over 3x minus 5, I'm going to say negative 1 over 2 times 3x minus 5. Does that make sense? I can't just put the half in the numerator and leave this weird 3-tiered fraction. Okay? So it's going to be negative 1 over 2 times 3x minus 5. And you don't have to simplify that. And then B was positive 1/2, so I'm going to say plus 1 over 2 times x minus 3. So if you actually took these 2 fractions and added them together, you would get to here. Yes.
Just replace it like negative.
We don't put decimals in fractions. No decimals in fractions. That's equally as unacceptable as a 3-tiered fraction. Okay. So we're not going to put a 0.5 in there. All right. Questions on that one? Okay. You guys try number 2. We probably aren't going to have time to get all the way through number 3, but that's okay. We're doing very well, guys. You're covering a ton of stuff today. Guys, that's where I'm starting. Okay.
Oh,
With the fact, do you see how you need to factor the left side?
yeah.
Okay.
It doesn't matter if you did the other one.
Nope, totally doesn't matter. If you did a over x plus 1 and b over x, that is fine. Because at the very end, when you write your answer, we would have the same two fractions.
That's okay. It's totally weird and different than anything you've had before.
Was the system a little nicer to solve? Yeah. All right, guys, that's where you should have ended up. Whatever order you started with, you should have had 2 over x plus 1 over x plus 1. How we doing? okay? Leave it there for a second. Guys, the third one is longer to start with when you look at it, but there's actually a shortcut in it. But I think I need a little more time than what we have left. So I think we're going to stop there for notes, and we'll do that last example next time, okay? Let's see, in your packet. Maybe I should just make you do odds. Let's see if I'm having you skip all these even. All right, we'll just do that. Do odds. So you're still skipping number 2, okay? But it's do the odds, and then on the partial fraction decomposition ones, which would be 13 and 15. There's 2 6s.
Yeah,
well,
I was about
looky
to say.
there, you get to skip 2 6s. 13 and 15. You know, try those. If you're stuck on them at all, like, it's okay if you don't get the partial fraction ones done, because we're gonna do more of those next time.
So are we not doing 13?
Try them. If you get stuck, it's okay. Then you also have a take-home quiz.
Oh, yeah.
Okay, it's not due next time though. So my expectations on it, because it is graded like a quiz, so you can use your notes. So it's open notes, but no calculator. I guess I should say no phone. No groups, no tutor / other teacher, anything like that. Like, don't make someone else do this for you. Guys, it's quiz grade adjustable, okay? So make sure that it's just to show you what you know and what you don't know. Thank you. Let's see, what else am I forgetting? Fully aware that I can't actually control this for you, but I also know that the majority of you are really good kids, and if I ask you to do it this way, that's how you're going to do it, okay? So let me pass those out. Does this make sense, everything? This isn't due for like 2 classes, right? It's on your assignment sheet when it's due. Are we okay with that? I'm not going to give you like a time that you should do it in, but if you're spending hours doing it, that's a bad sign for the test. I need to know things a little bit. Oh, so you can get one.
Yeah.
That's okay. You guys, I have your Unit 1 packets. If you would like those back. If you don't get one back to me, then... Or what? So I need to look at our math space stuff again. Become honors, but if you're looking for like basic skills, that's good for you. You can come in and I can it's not an easy.
Yeah, I just think like, I just want like 3 columns or like 3 days. And then, we kind of get like.
Are you not Branson? Oh, I did last time. Oh, yes, we are.
Oh, and guys, I think I reminded you last time, but Math Honor Society, if you're interested, you can scan the QR code up there. Basically, it's just hours, so, tutoring hours. Oh, you did, like, if you meet the requirements.
It's like YouTube. It's like, once you get out
Okay, guys, all right, on your way out if you want to grab it. I'll line them up right here. Adam, Jasmine.
Wait. We have to do
Dylan.
We have to like, do we, are we required?
Sophie. Reagan. Brendan.
Yeah, absolutely.
Alright, bye guys, have a good one. Yes.
So for my test, I was just wondering how I would go.
Oh, yeah. So, it's probably something that we should really figure out. Like, I'd give you the kind of see how things are going. You do the rest of the standard layer, and then we just have to go. So it would kind of be like mushy for a little while. If that makes sense.
I'll think about it.
Okay.